eventually, but that's not the easiest way to simplify this. So Max, you're suggesting that I can do 3 minus 27 plus 75.
Because the square applies to all three of the terms.
It does, but it's a different square. They're all not underneath the same square. That would be okay if we had the square root of 3 minus 27 plus 75, but that's not what we have here. We saw last week that we can't, a square root of a plus the square root of b is not equal to the square root of a plus b. We can't add across square roots, but what we can do that we saw last week is root a times root b is equal to root of ab. That's one thing we can do, but unfortunately we don't have a multiplication here. So we're left with possibly, if we can't add or subtract these terms, can we simplify them at all? Can I simplify the root of 27? How could I simplify the root of 27? Okay, Max is saying 3 square root 3. I think you're right. If we have root 27, we have to start breaking that up into its factors. So 27 can be written as 3 times 9. And 9 has a perfect square root. It has a nice square root. I mean, we could go one step further and say this is 3 times 3 times 3. And then we could take out a pair of 3's and write it out front. So we'd have 3 root 3. So we take out that pair of 3's and write one of them out front. Does everybody remember that from last week? The same thing, we could do the use the same idea to simplify root 75. 5 square root 3. So we could say 75 is 25 times 3, and 25 is 5 times 5. So we can take these 5's out because we have a pair, and write one of them out front. So we get left with 5 root 3. Okay, so let's see what we have here. Our expression then becomes root 3 minus 3 root 3 plus 5 root 3, all squared. Okay. So remember when we talk about like terms, we talk about variables talk about like terms as having the same variables. So these radicals also constitute like terms because the radical is the same. So if we think about it, if we have 1 root 3 and we're going to subtract 3 root 3's, and then we want to add 5 root 3's, we're always talking about root 3's. So that's good. It means they're all like terms. I'm just going to underline them and say they're all like terms now. So we can add and subtract them. So we have 1 minus 3 plus 5. So I think Edward's saying it's 3 root 3. Sorry, Max. We have 3 root 3's inside the brackets now. Does everybody see how we got that? Or are there any questions? Okay.
Yeah.
Cool. Now we just have this 3 root 3 all squared. So we're allowed to write it twice if we need to. 3 root 3, 3 root 3. And if we remember our rules for simplifying radicals from last week, we have the number part out front, the whole number part, and they get multiplied together. And we have the radical part, and they can be multiplied together. So we could say that this is 9 root 9. And root 9 is 3. So we get 27. Yeah. So when dealing with these questions, we're always kind of juggling squares and square roots. And we want to be able to factor things into their prime factorization so that we know if we can take the square root of them. That's most of breaking down square roots is just being able to write a number out in its prime factorization. Okay. Are there any questions about how we got 27 here? Just going to save my slides before we move on. Okay. I'm going to look at another problem here. It says, for what value of x does the square root of x cubed equal 27? For what value of x does the square root of x cubed equal 27? Brian says 3. Max says 9. How can we show this using algebra? Brian, what was your what were your steps for simplifying this? Find the factors of 27. Well, first I want to convert this. That's true that 27 is 3 times 3 times 3. First, the thing I want to do is convert the words here into an algebraic expression. So they're saying, from what value of x does, and here's where it starts, the square root of x cubed equals 27. So what does that look like as a mathematical expression? If I were to turn that part of the sentence into an equation, what would I write? Square root of x cubed is equal to 27, right? So we're talking about the square root of x cubed is equal to 27. So they're asking for what values of x is this equation true? Which basically means find x if we assume that this equation is true.
Here you square both sides so you can get rid of the square root sign.
We could square root both sides. We could square both sides, yeah. I want to use, before we do that, I don't want to deal with 27 squared. Because that's going to be quite a large number if we evaluate that.
729.
Yeah.
Why don't you use cube root?
Let's do, to take the cube root, Brian, is that what you mean?
Oh yeah. Sure.
Well, we have the square root here. This is the square root. When they don't write the 2, it means it's the square root, not the cube root. So we're not dealing with cube roots here, but I like your idea, Brian, of writing 27 as 3 times 3 times 3. So I'm just going to do that for a second. I'm going to write it as 3 cubed.
Yeah.
Now.
And then that will make it 3 to the 6.
Right. So let's square it now. So we could say, I'm going to, well, I should write that in the next step. I'm going to say x cubed, square root of x cubed, all squared is equal to 3 to the 3 all squared. And you're right, using our exponent rules that we're familiar with, this is going to be 3 to the power of 6.
And that's x to the power of 3.
Sorry, x to the power of
3.
3, right. The square and the square root, they're going to cancel each other. So we can say x cubed is equal to 3 to the power of 6.
And then you.
There's one thing I'm going to back up here. Instead of writing this as 3 to the 6, I'm actually going to keep this as 3 to the 2 for a second.
Yeah, because after you cube root both sides, that will make x equals the cubic root of 3 to the 3rd all to the 2nd. And then the cubed and the cube root will cancel out, so that leaves 3 to the 3 squared, which is 9.
Okay, but before we can take the cube root of both sides, we can't really do that right now because this is squared right here. We have a square.